A pH meter is an electronic device used for measuring the pH of a liquid. A typical pH meter consists of a special measuring probe connected to an electronic meter that measures and displays the pH reading. The probe is a key part of a pH meter. It is a rod-like structure usually made up of glass. At the bottom of the probe there is a bulb. The bulb is a sensitive part of the probe that contains the sensor. Never touch the bulb by hand and clean it with the help of an absorbent tissue paper with very soft hands, being careful not to rub the tissue against the glass bulb in order to avoid creating static. To measure the pH of a solution, the probe is dipped into the solution. The probe is fitted in an arm known as the probe arm. Calibration and use. For very precise work the pH meter should be calibrated before each measurement. For normal use calibration should be performed at the beginning of each day. The reason for this is that the glass electrode does not give a reproducible EMF over longer periods of time. Calibration should be performed with at least 2 standard buffer solutions that span the range of pH values to be measured. For general purposes buffers at penthouse 0401 and pH 10.00 are acceptable. The pH meter has one control to set the meter reading equal to the value of the first standard buffer and a second control which is used to adjust the meter reading to the value of the second buffer. A third control allows the temperature to be set. Standard buffer sachets, which can be obtained from a variety of suppliers, usually state how the buffer value changes with temperature. For more precise measurements, a 3-buffer solution calibration is preferred. As penthouse 7 is essentially a 0-point calibration, calibrating at penthouse 7 first, calibrating at the pH closest to the point of interest second and checking the third point will provide a more linear accuracy to what is essentially a non-linear problem. Some meters will allow a 3-point calibration and that is the preferred scheme for the most accurate work. Higher quality meters will have a provision to account for temperature coefficient correction, and high-end pH probes have temperature probes built in. The calibration process correlates the voltage produced by the probe with a pH scale. After each single measurement, the probe is rinsed with distilled water or deionized water to remove any traces of the solution being measured, blotted with a scientific wipe to absorb any remaining water which could dilute the sample and thus alter the reading, and then quickly immersed in another solution. Cleaning and troubleshooting of the glass probes. Occasionally, the probe may be cleaned using pH electrode cleaning solution. Generally a 0.1 am solution of hydrochloric acid is used, having a pH of 1. Alternatively a dilute solution of ammonium fluoride can be used. To avoid unexpected problems, the best practice is however to always refer to the electrode manufacturer recommendations or to a classical textbook of analytical chemistry. Types of pH meters. pH meters range from simple and inexpensive pen-like devices to complex and expensive laboratory instruments with computer interfaces and several inputs for indicator and temperature measurements to be entered to adjust for the slight variation in pH caused by temperature. Specialty meters and probes are available for use in special applications, harsh environments, etc. There are also holographic pH sensors, which allow the measurement pH colorimetrically. History. The first commercial pH meters were built around 1936 by Radiometer in Denmark and by Arnold Orve Beckmann in the United States. While Beckmann was an assistant professor of chemistry at the California Institute of Technology, he was asked to devise a quick and accurate method for measuring the acidity of lemon juice for the California Fruit Growers Exchange. Beckmann's invention helped him to launch the Beckmann Instruments Company. In 2004 the Beckmann pH meter was designated an ACS National Historic Chemical Landmark in recognition of its significance as the first commercially successful electronic pH meter. In the 1970s Genco Electronics of Taiwan designed and manufactured the first portable digital pH meter. This meter was sold under Cole Palmer's label. Building a pH meter. Because the circuitry of a basic pH meter is quite simple, it is possible to build a serviceable pH meter or pH controller with parts available at a neighborhood electronics retailer. For a walkthrough of how to build the simplest possible pH meter or a detailed description of how to build a pH meter pH controller, see the pH pages. Serviceable pH meters can be built from any operational amplifier with a high input impedance, such as the common and inexpensive National Semiconductor TLO82 or its equivalent. See also, glass electrode, ion-selective electrodes, ISFET pH electrode, pH, potentiometry, quinidrone electrode, saturated calomel electrode, silver chloride electrode, standard hydrogen electrode, pH indicator. References. External links. Introduction to Penthouse Excellent overview of pH and pH measurement at the Omega Engineering website. Development of the Beckman pH meter National Historic Chemical Landmark of the American Chemical Society. Digital analog printer freeware compatible with the device shown in the article to monitor the pH in real time.